Hi guys, so far in this chapter I covered motion in one dimensions. We mostly talked about an object moving in a straight line. So if this is object which is moving in a straight line, so we talked about that a lot. And we talked about distance, displacement, velocity, acceleration, and finally I reached at to derive equations of motion, that is equal to v equal to u plus at and s equal to ut plus half at square and v square minus u square equal to 2as. So these are the equations of motions we covered till now. If an object moves in a straight line along in this axis, we consider that as positive x-axis and negative x-axis in this straight line. So far so good, but if we change this as a vertical position, it means suppose if I take like this situation, this is also one dimension. Suppose if I take this as 0, so this goes to negative y-axis and this goes to positive y-axis. So in this case, how we define displacement? So the distance between 2 points, suppose here it is x, suppose this is I take as little x, small x naught. So the displacement along in this is the displacement. I can get that x naught minus 0, that equal to x naught. We define everything displacement in terms of x naught. So likely here s is also displacement along x-axis. But when we take in the vertical, suppose if an object is falling due to gravity, so we need to consider that along y-axis. So how we consider it here along x-axis? As like that, we need to consider here also along y-axis. So today I will talk about this. So this comes under motion free fall. Motion under free fall. So free fall we define like this. The motion of an object is only due to gravity. We know that if there is no external force, suppose here you can take in this situation, so in the presence of air, if you drop a hammer and a feather, so it is in the presence of air medium. So what happens? The air opposes air resistance, so the feather will fall later than the hammer. But when you repeat the same experiment in vacuum, so that's what they did in the moon, where there is no vacuum. So if you do the same experiment in the absence of atmosphere, so in the vacuum, so on these two objects, feather and the hammer, the acceleration due to that place will be acts on same. So in this case, the acceleration due to gravity, so that is on earth, so we will represent that its magnitude as 9.8 meter per second square. So that is the acceleration due to gravity, its magnitude. But if you can write this object's acceleration, these objects are falling. They are falling due to only gravity. Forget for a moment that air resistance and everything and all. So in this case, if you write that acceleration of this object, so that acceleration we will write always negative 9.8 meter per second. So this negative sign shows that the object is falling freely. So how this object acceleration is negative? So let us think that first. So today, whichever the concept I am going to discuss, that everything is due to only along motion along y-axis. Whatever the graph I am going to plot, so that is only along y-axis. And here we neglected for a moment air resistance and friction in air and all external forces we neglected. So we were talking about only the gravity which is acting on objects, on falling objects. So for that, so let me take a case. So here I am having an object. So I am trying to drop the object from a tall building. First I would like to plot position versus time graph. Suppose if I plot position versus time graph in this special case. So till now we plot the position versus time graph along x-axis and the time axis. Now in this case the object is falling, so we need to mind that axis. So time, always x-axis is time axis, time is along on this axis. And now position I should mention at here, since it is a positive y-axis. Now here we can see the object starts from at here at 0, then after it covers at a distance of minus 9.8, roughly if we can take at here, so that is minus 9.8 after 2 seconds, and after 3 seconds it covers a minus 58. So like this point, so this is a 58.8 which is minus, and this is minus 29.4. So like that, if you can take, this is all the negatives, 98.0 for the third objects, it's somewhere at here. So we were getting the position versus displacement graph, it's supposed to be a curve. So this is along negative y-axis. Or a simple graph if I plot without taking the numbers. So I will plot only along the time axis, and I take here one more. So this is my position axis. So this is at origin. So this is negative y-axis and this is time axis. So when we draw free fall position versus time. So here position is along y-axis, position versus time graph. So this is what something it looks like. So the negative sign shows that an object is falling downwards. The displacement is negative. If this is position versus time graph, what about the velocity versus time graph? We know that the slope of this curve, slope of position versus time curve, gives velocity. So here velocity also we define that velocity v equal to the rate of change of displacement dy by dt. So here comes along with negative sign, yeah, because displacement is negative. So in that case, if we plot velocity versus time graph, so the velocity versus time graph also comes under the negative axis. Now if I take this as negative velocity, so this is negative velocity and this is time, and this curve slopes gives a straight line, so that is straight line. So this is the velocity versus time graph for an object is falling freely from certain height. Now if this is velocity versus time graph, what about acceleration? So we define acceleration that the rate of change of velocity dv by dt. So here velocity is negative, so acceleration also negative. So if I plot the acceleration versus time graph, suppose this is time and this is acceleration, which is negative, and we need to find this slope of velocity versus time graph for an object which is falling from certain height. So since it's a straight line, the straight line slopes is a constant, so we can get a constant value. So if it is on earth, so this value is 9.8 meter per second square, which is negative. So this graph represents the acceleration versus time graph for a free fall body, free fall object from certain height. I hope you are getting the realistic mean of the free fall. So one thing here we need to mind, since the object is falling from top certain height, so here itself we were considering as a coordinate axis. So this is better representation to you. If I take a coordinate axis at here, let me change the color so that it can be visible more. So in this coordinate axis, so we need to draw only along that particular coordinate. Now the object is falling at here, the object is falling. Suppose here you can consider as 0 and it is falling negative y-axis. So this is negative y-axis and this is the time. So whatever we draw, position versus time graph, that will be along in this axis only. So if that was position versus time graph, so here I represented that in terms of y versus t. So because always motion is along the y-axis, y versus t, so we plotted like this, position versus time. So once we know the position versus time, later we came across the velocity versus time. So here the velocity also negative since it's falling. So this is a velocity versus time graph. Here we got the straight line in fourth quadrant. I hope you know what is the meaning of fourth quadrant. And similarly, the acceleration versus time graph, it's a constant acceleration. By assuming we are doing this experiment on Earth, so Earth is having the acceleration minus 9.8 meter per second. So these three graphs are represents a free fall from certain height. If it's a free fall from certain height, so these are the position, displacement and acceleration graphs. And what about the equations of motion? How the equations of motions will change? We know that v equal to u plus at and s equal to ut plus half at square and v square minus u square equal to 2as. So these are the three equations of motions. But these three equations of motion will be changed in free fall condition. In free fall, acceleration a equal to always minus g on earth. Remember this carefully. In free fall condition, acceleration is always minus g. So the rest of the terms, if we do not change, one quantity I would like to change, so that is the s. S we define as displacement. So in the y-axis we define displacement. Suppose the shortest distance between initial and final position is defined as displacement. So in this case, if we take that displacement, initial position along y-axis as y and final position as y naught, so we define displacement as s equal to y minus y naught. So this is one of change we will make in the free fall condition. So the two changes are at here. So the displacement we will represent in terms of s equal to y minus y naught, because y is initial position and y naught equal to final position. The distance between initial and final position is called displacement, and acceleration always represent minus g. Now by taking these changes, the above three equations will be changed. In free fall condition, v equal to u minus gt, and here s I can write that y minus y naught, which equal to ut minus half gt square, and third equation v square minus u square equal to minus 2g y minus y naught. So these are the three changes will happens in the equations of motions. First change is acceleration due to gravity. At g value we need to substitute only magnitude, that is 9.8 meter per second square. It is on earth. So the equations of motions also changes. The three equations of motions also changes in the free fall condition. So in the free fall condition, the three equations of motion, v equal to u minus gt, and s equal to, here s equal to y minus y naught, which equal to ut minus half gt square, and v square minus u square equal to minus 2gs, here s equal to y minus y naught. So which I am highlighting y minus y naught, that is means nothing but s. So, similarly in the displacement second equation of motion, so this is also we highlighted here. So this is also displacement. So this we will represent as s in ordinary equations of motions, not in free fall condition. Now let us change a situation. So free fall is nothing but if an object is moving upward direction. Suppose, let me take one more example at here. So I am having a ball which is going upward direction, and again it is coming back in my hands. Suppose take this, let me put it down. Yeah, this is a situation. Now I am throwing a ball from my hand in upward direction. What happens? The ball will come back. I can able to catch. Now, as per I said, if gravity is acting alone on an object, so that we define as free fall. So on this motion, from object is going from my hand to the above. After that, the object velocity at the highest point will become 0. And when the velocity becomes 0, again object will falls back. So let us try to draw to this case the graphs. First I would like to draw the displacement versus time graph. Suppose if I take, this is a displacement along y-axis, and if I take this as a time axis, so I can mention this is time and this is displacement. Displacement versus time. Now here the initial position y equal to 0. So here the displacement is along y-axis. Now the ball will move from 0 and it reaches to certain height in the positive and again it falls back. So this represents the displacement versus time graph for an object which is thrown like this. Yeah, from 0 it is going up, so the displacement is positive. At the top, it's again from there it is coming back, so the displacement is negative. So this is the displacement versus time graph. Suppose if we want to represent the velocity versus time graph to this case. So the velocity versus time graph to this case is something is different. Suppose if we take this velocity and time. So in my hand, initially I am applying a force. So the object is moving with that velocity. So initially the object is already having the velocity. So let me move this to parallel to get here. Now in this case, if you can see properly my blue point, so from at here initially let the object is having the velocity. Now the velocity when it goes to top is becomes 0, and again when it falls back the velocity is increases. That's what really happens when we throw objects. When we throw objects in upward direction, so whatever the velocity is in our hand, that is the velocity of the object. It is going upward direction. So after reaching certain height, it is falling back. So the velocity at that highest point. So at the highest point, the velocity will become 0. Precisely we can say the y component of velocity. So for a moment you take that as granted, the velocity at the highest point equal to 0. Now after that, again the object is falling back. It means its velocity increases. From 0 to it is again increases. Now in that case the increasing velocity you have to plot in the negative velocities. Now if that is the velocity versus time, what about the acceleration? Try to plot the acceleration versus time graph for this case. The acceleration versus time graph, if I take at here acceleration, acceleration is along y-axis and the time. Now acceleration versus time. If the velocity is, if you find the slope of this curve, now here the velocity is decreasing. The velocity is maximum at here and velocity is decreasing. Now if I find this acceleration equal to the rate of change of velocity, now we will get that acceleration as a constant acceleration. So I will draw a line which is in the negative axis. So this is acceleration equal to minus, if it is on earth, 9.8 meter per second square. So this acceleration is acceleration due to gravity. So we will feel wonder at here why the acceleration is negative when the object is moving upward direction. Yeah, when the object is moving upward direction, so what happens? The velocity of the object is decreases. Why the velocity of the object is decreases? Because there is a force which is acting on the object. Who is that? That is the acceleration due to gravity. So that acceleration due to gravity acts in opposite direction. So that's the reason the speed of the object becomes less, decreases when object is moving upward direction. So in this case also we were neglecting about the air resistance and friction in the air and all, everything is we neglecting. So when object we throw, the object velocity decreases. So what could be the reason? That is the reason acceleration due to gravity which is acting opposite in direction. Now at the top, the object velocity equal to 0, but still acceleration is constant at the top. Object velocity is 0, but acceleration remains constant. So that you can understand if you know the differentiation. Acceleration A equal to dv by dt, the rate of change of velocity. If the velocity equal to 0, A equal to d by dt of 0. The differentiation of 0 value goes to constant. So it means that acceleration is constant here. The differentiation of velocity equal to 0. So it means that acceleration is constant. Since here acceleration is already negative, so here if you can take negative sign, the same negative sign will be comes up. Now that is when object is moving up. When it is falling, it means during descent. When object falls from height, what happens? Its velocity increases. Its velocity increases, yeah, that's why it's negative velocity. Its velocity will become more negative. So if you can clearly observe the graph at here, so this is the point. If you can make a top, this is the point at the top. At top, the object displacement is 0. Now at the same point, if you can draw a line from there to at here, if you can see the velocity here, it is touching at velocity equal to 0. But velocity equal to 0. What about the acceleration at the same point? Acceleration at the same point remains constant. So it do not change at all. So this is the acceleration at the same point. Now when object is falling, so this is during the descent time, falling time. Now displacement is increasing, so its velocity, the negative velocity, here the velocity is increasing but in the negative direction. So because velocity is a vector, it is increasing in negative direction, but acceleration remains constant. So in free fall, what I mean to say that in free fall, when object is moving upward or when object is moving downward, so in whichever the situation is, the acceleration is always negative. So keep it that point in back of your head. Again I am repeating, during free fall means only the force acceleration due to gravity acts on an object. So in that case, when object is moving forward or moving upward direction or falling downward direction or during ascent or during descent, so in any case the acceleration due to gravity is always negative. So in the both of the cases, the free fall kinematic equations remains same. there is no change in kinematic equations, the three equations of motion, free fall, both in the upward direction and the downward direction. So particularly at here, I have taken that V naught here, V naught equal to initial velocity, equal to U initial velocity. And V equal to final velocity. And Y minus Y naught, which equal to displacement S. And acceleration of gravity A equal to negative G. So this is the main change during the free fall. So this is one of the key point you need to remember. Free fall means nothing but it's not only fall. So it is something, the one and only gravity force acts on an object. So during free fall, the acceleration of gravity is always negative, whether it is during ascent or during descent. So when it is acting while in a moving forward direction, so that's the reason the object speed decreases. So when object is falling, the acceleration of gravity also acts constantly. So that's the reason its velocity increases. So that's all about free fall. So here I'm having a situation, a condition of the free fall. So this tells about the three values: displacement, velocity and acceleration. So during the free fall motion, so this is a situation when object is thrown from a vertical building of height 50 meters. So here we consider at different positions A, B, C and D. So initially at A, when time t equal to 0, at A, at point A, time t equal to 0, it means the object is not at all dropped. So when time t equal to 0, the vertical displacement also at A equal to 0, but the initial velocity at A, the velocity which an object is throwing, so that is 20 meters per second. And at this point the acceleration, since it's a free fall, the acceleration at the point we have to take as minus 9.8 meters per second. Now if you notice, so this value minus 9.8 meter per second is remains constant during this all motion. From the object is going from down and again it is a falling back. During all the motion, the acceleration due to gravity remains constant. But rest of the values gets changed because position changes and velocity also changes and time also changes. But acceleration remains constant. So that is negative 9.8 meter per second. So that is due to free fall. Yeah, this is all about free fall. So I hope I made things clear. So here A we will replace in equations of motion with negative G.